All right, everybody, welcome back. It's a cloudy day here in Champaign if you're elsewhere. I know it seems to be cloudy in a lot of parts of the country right now, some apocalyptic clouds out west. So I hope if you are on the West Coast, although I don't know if you're on the West Coast whether or not you're joining for these because it's a little earlier where you are. But I hope if you're out there, you're okay. And, you know, dealing with there seems to be a lot of challenges in our world today. So whatever one is affecting you, I hope you're all right. Today's lesson is another case where, you know, most of the important lesson content is delivered in one of the walkthroughs, so I'm not gonna reiterate that. But overall, the primary, you know, new instructional point about that we're covering today is about this value called null. And null is, and this is one of those things that, you know, in this course, there are topics that reveal themselves in layers, one after another. So this is not the first time we're going to talk about null. And we're going to come back and talk about null in maybe a month when we talk about a concept called references, because then null is actually going to make a lot more sense, like what null is. But for now, you can think of null as a literal value that you can use to initialize any variable that stores an object. The one type of object that we've been working with, well, actually that's not true. We have a couple types of objects because arrays in Java are also objects. But the new type of object, the first object that we really started to kind of experience as an object were strings, which we talked about this week. So this is a good place to kind of stop, point out this feature of Java, and talk a little bit about what the consequences are. So null, again, is a special literal value. You can use it in your program on the right side of an assignment for a variable of an object type. You can also pass it as a parameter to any method that expects an object variable. And that can be, for now, a string. Arrays can be set to null. And this, by doing this, it's essentially sort of equivalent to not setting a value to the object. So you might think, well, you know, isn't the empty string just an empty string object? But it's not really, because it's still a string. It's just a string that doesn't happen to have any characters in it. Whereas null is the complete absence of any content. And this is one of the reasons why null can be used to initialize or as a parameter to replace any object type, because it essentially means the variable doesn't store anything. You can think of it as being empty. I think Python has this in the form of none. That's the equivalent in Python. There are other languages that have this feature, and Java, I think, sort of inherited this feature from earlier programming languages. As a reminder, please ask questions. Some of the questions you guys are asking during the walkthrough, I'm happy to answer, but they're really better for the help site. Like the question about the quiz documentation, just ask that on the help site. Sorry, not on the help site, on the forum. And in fact, I'll just ask you, the person who asked that, to just ask that on the forum. The reason I do that is because when I answer it on the forum, everybody, or when someone answers on the forum, everybody knows, right? As opposed to just now where it's just a few of us. So yeah, please go ahead, ask that. It's a great question for the forum. In general, if we expect you to work with a particular type of object in Java like strings, we will provide access to the documentation. We're not, like I said, we don't expect you to memorize all of the string methods. And so yeah, you'll have access to that. Okay, so null, so null is this variable or this literal that essentially means that the object is empty. The object variable is empty. Note that there is no, the other thing to understand about null is that you cannot use null to initialize a variable of a primitive type. There's no equivalent to null for primitive types. Before I use a variable of a primitive type, I have to assign it a value, some integer value. That value could be 0, but that's still an integer value, or it could be -1 or whatever. But there's no equivalent of null for the primitive types. Every primitive type, before I use it, Java will insist that I assign it a value. Whereas with a string, as you can see here on what will become line 1, I'm allowed to initialize it with null. And this essentially tells Java this string the string variable is empty. And here's the problem with null. So we can talk a little bit about kind of the history of null. And if you guys really want to get me out to a digression, we can talk about some other newer variants of Java, not Java itself, but newer Java-like programming languages that avoid, that really have as a design goal, avoiding problems with null. So here's the problem with null, and you can illustrate this in just 2 lines, but obviously this type of thing doesn't happen very often. But the problem is that if I have a variable that is empty, that has been set to the value null, or if somebody passed null as a parameter to my function, and I try to do anything with that variable that involves dot notation, essentially. So if I try to call a method on that variable, as we've been doing with strings, things go boom, right? This is a error. And the bad thing about this, and we're going to talk, again, we'll peel off another layer of null next week when we talk about what actually happens when your program is run. So that's one of the topics that we'll get to in one of next week's lessons, is this idea of the different steps that Java goes through when it actually runs your program. So there's really 2 phases. There's this first phase that's known as compilation, and that's sort of when Java takes the code and does some analysis on it and transforms it into this different format. That other format is actually what's executed. When you run code in our playground, we're actually doing both steps back to back without interruption, so you don't actually see them as separate. But next week, when we do the lesson on compilation, I'll actually show you each one of them being performed independently. We'll talk about what happens at each stage. The reason this is important with null is that the first step of this process is typically performed by developers as they're working on a program. So when you're building your app, that's going to change the world, that you're building with the knowledge that you've gained in this class, and you're working on it locally and you're testing it, every time you test it, you have to compile it. And the compiler can find certain types of problems in your code. So here's an example, right? When I had this, when I tried to do this is an example of a compiler error. We talked a little bit about this when we did the lesson on debugging. This means that the compiler has found a problem with your code. And in this case, the problem the compiler has found is that you are trying to assign a null value to a variable of a type that can't be assigned null. So the compiler knows how to check your code for certain problems. It does not know how to check your code for null. Or the Java compiler doesn't do a very good job of this, clearly, because here's an example, right? I have a variable called test. I initialize it to null on line 1, and then immediately on line 2, I try to do something unsafe with that variable. And the compiler here has no problem. The error message that's being generated now is actually occurring when the program is executed. And that is a much, much, much more problematic type of error. So, and again, we'll come back and we'll cover this in more detail when we talk about compilation, which is a really fun lesson. One way to think about it is the compilation step exposes errors that only the developer sees, because in order to actually get your code to run, you have to fix those problems. So if the compiler identifies a problem with the code, you actually have to fix it before it'll run. If it starts to run and then there's a problem, that causes a crash. And those are typically visible to the user. So, you try to open an app on your phone and it says, unfortunately, this app has stopped. That's actually Android's nice way of delivering typically what is some type of runtime error. It might even actually be a null pointer exception. The Android doesn't tell the user there was a null pointer exception. They'd be like, oh my gosh, what is my computer trying to tell me? I don't get this. Most people that use Android phones aren't computer scientists or programmers. So it has a nicer warning message, but a lot of times what causes those are errors like this one. The other way I can sort of convince you of the difference of this is let's put a print statement here, and you can see when the code runs, I see this print statement, right? So I see that it printed this. So it clearly executed line 1 before disaster occurred on line 3. If I have a compiler error, you can see that I don't see started at all. So this code never ran. because it didn't pass that first set of checks. And so, one of the interesting stories that's been going on over the past couple decades when you look at how people build software. So, one of the really exciting things that's happened in the world, of course, is that computers have gotten faster and faster, at an astonishing rate, during your lifetimes. And it's not clear that this is going to continue at quite the same rate going forward, but the fact that it has, been on this exponential curve has been shocking, right? It really is one of the most rapid technological changes, I think, that we've ever witnessed in human history. Particularly, it's like, okay, you didn't have fire and then you had fire. That's a big leap, right? But it's just it's like a step function, right? With computers, it's like this exponential that we've been riding for decades, and it's really just astonishing. So one of the things that's happened is that computers can now run a lot more powerful programs. The other thing that's happening, though, is that power is also being turned back to help the process of developing software. So one of the things, computers are better at doing everything than they were 10 years ago. They're just a lot faster. So, in the same amount of time to us, they can perform a lot more computation. One of the ways that we're utilizing that is we're building and we're deploying more complex programs. For example, even the website that we're using for this class would have probably been inconceivable 10 years ago, definitely 20 years ago. It's just actually doing too much on your computer, right, to deliver the walkthroughs and the videos and stuff like that. I mean, if you tried to load this particularly on a phone 10 years ago, it would have been almost unusable. And so it's just been that explosion of computing power that's facilitated a lot of different types of applications. But again, one of the things that we're doing with that, because we're software developers and we need help with this stuff, because it's hard, is we're using it to build better tools and in some cases better programming languages that allow us to do more work more quickly and more safely. And so one of the things that computers are starting to be able to do is provide you with more help as you're writing your program. And so, for example, the fact that you can do this in Java, that just these 3 lines, and in fact, these two lines, is almost criminal, right? In the sense that, this is you're looking at it with your human eyes, and you're like, okay, I see a variable called test. It's set to null on line 2. And then immediately on the next line, I try to use dot notation on it. I know what's going to happen. Why does Java allow me to even run this code? And the reason is the Java compiler, that first stage that we'll talk about next week, is old. And at the time, it was more important for it to finish its work quickly rather than do more sophisticated analysis that might allow it to detect problems like this. So again, this is a cool story. But one that we'll get into more next week. Same about the coder's question. Let's put that on the forum. That's also been asked and answered a bunch of times. You guys are responsible for reading the forum posts. That's an important aspect of this class. We always get questions from people that miss something or whatever, and a lot of times those things have been discussed on the forum. And a lot of times there's been announcements about them on the forum. So please make sure that you are keeping up with those. If we announce something, or if there's kind of a high-profile discussion of a particular topic on the forum, you're responsible for that content. That's considered, one of the things you're supposed to know. And if you show up at a quiz and you're not prepared, at that point, it's on you. I mean, we can only do what we can to keep you guys up to date. I can't personally explain things to every student in the class. I don't have time for that. So that's why we've built some of the tools that we do use to try to allow you to ask questions and gain information about the class. So please do use them. They're entirely for your benefit. Well, I shouldn't say that. They're also for our benefit. It makes things a lot easier for us to be able to communicate with you in a larger group. Okay. So I will answer that question because that's an interesting question. So let's talk. So someone asked if there's a difference between. I'll get back to null in a minute, but I like this question. So is there a difference between this and this? And you can see from a functional perspective, there is no difference. I mean, these both work, they both kick in, and they'll both behave in the exactly the same way. There is a difference. The difference is interesting, but not important, and probably best. So again, I really like this question. I know that I haven't answered it. I mean, I did answer it. The answer is yes, but the rest of the answer is more interesting. queue up this question for about a month from now. When we talk about references, and when we talk about object references, which we will, once we talk more about objects and how to design them, we'll actually talk a little bit about, we'll become more specific about what we're doing when we use object variables. And that'll be a great time to ask this question, because then you'll know enough about kind of the surrounding environment for it to make sense, right? And I'll just give you a little preview of that. So these two strings have the same content. We would agree on this, right? When we, and this is something you're going to get practice on the homework problem coming up. So I guess I'm giving away a little bit of the answer for that, but not the whole thing. When you have a string and you want to compare it to another string, if you try something like this, it's not going to do what you think. So for example, this is weird, right? I mean, I got two strings that have the same contents, but when I use the double equality operator that I'm used to using with primitive types, on strings, it doesn't work. Now, the reason for that is that strings have a built-in method. One of those string methods that we've been using is called equals. And this allows you to compare the contents of two different strings. So this is the right way to compare two strings, is to use one string, call this what's called the dot equals method. And this is something else we'll come back to and talk about more when we talk about objects, because this is a really important part of the Java programming language. But strings have this capability, so I call dot equals, I pass the other string as the parameter to that method, and that method will return true if the two are equal and false if they're not. Right, in this case, they have different contents. However, let me show you something interesting. So this is always going to work. But let's go back and let's use this notation for both of these, okay? And this is another place where strings seem, there are parts of Java that just seem almost like they were booby-trapped, like they're kind of designed in a way. I mean, Java was not designed as an instructional language. It was never designed as an ideal language to teach students who are learning how to program. And I think in some ways it's not an ideal language to do that, but it's good enough, and I think we do a really good job of helping you with it. But here's one of the things about it that's confusing, which is I just ran this program and it printed true, okay? So I just told you not to use this to compare two strings, and you shouldn't, because it doesn't always do the right thing. And in fact, here, let me show you an example of it doing the wrong thing. These two strings I should consider equal, but that double equals equality considers them false. So here is the difference. I'm sort of illustrating the difference between these two approaches. And I'm not going to explain why this is the case. Again, we'll talk about that more when I'll be happy to talk about exactly what's going on later. But again, this is one of those places where Java is really kind of like, there's this unfortunate feature of Java that's intersecting with our learning. What I will tell you is that if you have two strings and you need to compare them, this is always the right way to do it. Using double equals is never the right way to do it. This method that every string has compares its contents with the contents of another string and returns true if they're the same and false if they're not. And again, it's always the right way to compare two strings. Good question. All right. So null, right? So and I'll go through this. The fun story about null is that the person who's taken credit for null, a man named Tony Hoare, who was involved, he's a famous computer scientist who was involved in the design of some early programming languages, has referred to it as his billion-dollar mistake. And the reason being, it has caused so much damage over the years because programs that don't handle null carefully crash. And those crashes cause, lost productivity, lost dollars, hopefully not lost lives, but there have been instances where programs have, buggy programs have managed to kill people. So, learning, and to some degree, like I said, there are newer programming languages that have as one of their primary goals avoiding these types of problems. And so you can certainly make an argument that this type of value is not even needed. There are programming languages that completely avoid any idea of this type of null value, and also avoid all the problems that go along with it, meaning that they don't have this particular type of crash. So, the number, so the lesson goes on to talk about kind of how do we work with null safely. And the number one way to do that is to make sure, and this is just one of these like little bits of paranoia that you start to develop as a programmer working in Java. And it's never a bad thing to do, right? I mean, being suspicious of any variable that could contain null, or the variable that could be empty, is a really good way to do things. And dealing with it's not hard, right? It's not like it's hard code to write. You just have to remember to do it. And so the first step that we are going to undertake going forward is whenever we have a method that could receive a variable that could contain null or could be empty, we're going to check for that, right? So the first thing we're going to do is we're going to check for null. In this particular example, this function takes two parameters, or two arguments. The first one is a string. The second one is a car. Primitive types cannot be null, so this variable is okay. Strings can be null, and so this variable is not okay, in the sense that we can't trust it. It could be null. So for example, if I wanted to write my usual, character counting function here, where I'm basically going through the string, one value at a time, and I'm going to say if toCount is equal to input.char at I, count plus plus, and then I need a count variable here. I'm going to return count. So this is fine, right? I mean, this is how we've done this method, and it will work. So if I do count characters and I pass it test and character t, that should print 2, perfect. But the problem is, what if I receive as my first input null? And now I've got this problem, right? I have this is one of the problems null can cause. And this is typically how null causes this problem. It's usually not that I mean, this type of mistake, well, sorry. Let me go back and get the original content. So when we say something like, string s is equal to null, and then you print, the length on the next line, people don't do this. I mean, I'm not saying I've never seen somebody do it. I'm pretty sure I have seen somebody write this code, and I think I've probably written it myself before in certain ways, variants of it, right? But this is like, when it's 5:30 in the morning and you've been up all night and you're blurry-eyed and you can barely think straight and you're just trying to this one last thing to work, and you're just not at your best, right? I mean, most programmers don't write this line of code. But a lot of programmers will make this mistake where they will assume that one of the inputs to a function that they're writing or a method that they're working on is non-null, and then somebody will pass it null. And frequently, again, the person that passed null didn't know that they were doing that either. A lot of times this happens because a user provides a bad value in a form or something like that, and then that value slips into the program and essentially will kind of wreak a path of destruction, right? So you don't want your app to crash because the user didn't understand what you were supposed to fill into the form and put in a bad value or something like that. And so, if someone else is going to call your method and that they might, I mean, I wouldn't say that. I think it's a simpler, you shouldn't only handle null if you think something should be null. You should handle null if you are not 100% certain that it cannot be null. If you write a method and you're the only person that calls it ever, and you make sure that you never call it with null, fine, right? And in fact, I think in the example that we do later in the lesson, we go through an example where we use a helper function and we don't handle null in the helper function because we're only calling it from the main function, and so it's okay. But if someone else is going to call your function, like our test suites, or someone who's using your code, or maybe you another day when you forgot exactly whether it handles null properly, it's up to you to check and to make it safe. So, like I said, it's very easy. All we need to do is check for null here, and it's really interesting. Now it seems like I'm contradicting myself because a minute ago I said if I want to check if two strings are equal, I use that dot equals method. The only time, and again, this is one of those things that you're just going to have to trust me on, and then we'll explain it more in the future as we kind of take off another layer or build another layer of your understanding of how Java works. This is how you check for null. If I have a variable that could be null, variable on left side, null on right side, double equal sign, this is how you check for null. So this conditional expression will be true if input is null. And then the idea is that I do something in here where I return a value. And what you return is, if you're designing your own code, it's up to you. When you're working on the homework problems of this class, we will tell you what to put in there. In this case, I'm just going to return 0. It seems like it's a safe value to return. I mean, I can't. Here's the thing: if you've typically, when you're looking for null values, if you find one, you can't go on. So I have to make sure that if input is null, I never get to this this statement, because if input is null and I try to find its length, that is where the program is going to crash. And so I check for null and I return something, and that means that if I reach line 6, input cannot be null. And again, the other mistake people make is that they'll and this is a hard thing to do, or they'll do something like this, right? They'll say if input.length is equal to 0, return 0, right? Because it's like, well, if the string has no characters, then it can't contain any of the characters that were the character that was passed. So that's, it's like a little optimization. But again, the problem here is that now things go boom. So that null check really has to be the first thing that you do in the program. And at that point, we're good. Now I handle null properly, and there's no way for someone else to make this method crash. Another thing, somebody pointed out in the forum that I think is actually kind of a nice feature of Java. Let's look at this together. We'll talk about this more next week. What could be a little preview. I can also do this. And this is going to work in the same way. Oh, if I can get it to run. Okay. And now if I pass an empty string, it's going to work the same way. And let me put a print statement right here. So we can see when we get to the point where we're actually starting the loop. Just so that I show you that never happens, right? So if I pass the empty string, I never start the loop. In this case, if I pass a string with 2 t's or 3 t's, I do run the loop. Why can I do this? And so this goes back to something that we talked about. And again, this is a topic that we'll cover again next week. When we talked about how conditional expressions are evaluated. Remember we pointed out that Java works through these from left to right. And what that means is that if I, and it stops, it works from left to right, and it stops as soon as it finds something that's true in this case. So the idea here is that, let's say input is null, Java first evaluates this part of the conditional expression and it's true, and it doesn't even evaluate this part of the conditional expression at all. It just enters the if statement and returns. If input is not null, then Java, so this part is false, right? So if input's not null, then this part is false, and Java moves on to the right side of this conditional expression and actually will evaluate it. But at that point, it's safe to check the length of input because we know it's not null. And so this short circuit evaluation that Java does, where it will stop evaluating, in this case, an OR statement as soon as it knows the answer, is handy, right? Because it allows us to combine 2 checks into one statement. Now, again, you have to make sure that the first thing you do at the left of your compound conditional is check for null. If you put these in the other order, right? So if I do if input.length is equal to 0 or input is equal to null, it works fine if I give it this string, it works fine if I give an empty string, but if I give it null, it crashes again. Right. So yeah, ways to avoid null. Yeah, empty string and void. Yeah, great question. Or null and void, right? So yeah, void is a strange thing, right? Really, the only place that you ever see void, and I was thinking about this the other day. I'm like, can I say this categorically? Because that's the problem with Java. Like these mature programming languages, there's always some strange exception somewhere. So I'll just say it, and then if I'm wrong, somebody can correct me. One of the people, on my staff that knows Java, knows all the parts of Java on the back of their hand, and I don't always remember. So I'm pretty confident that the only place you will ever see void in Java is as part of a method declaration for a method that is not returned. That's it. And so even though void looks like a type, right? So that's the thing that's weird, right? it's like, okay, you know, if I think about my typical, let's just change this to be a lot simpler. If I think about my typical method declaration, I've got the return type, the name, the parameter list with, and then the body. And in this case, the return type is int, and I'm returning an int, so I'm good. That's just going to return 0. If I replace this with void, it's in a position where I would expect there to be a type, but it's not a type. It can't be used. So you might think, well, I can use void other places. I use int or string or return type. No, this is like the only place you can use void. Hold on a sec. Let me do something kind of fun for a minute. Well, actually, hold on. I'm going to, since you asked, I'm going to do a brief digression here. So here's how I'm going to try to answer this question. So I'm going way off the rails here, so just excuse me, but this will be fun. One of the first steps that occurs when you try to run a program is that the compiler has to parse it. So it has to take the text that you wrote and convert it into a format that it can work with. The way it does that is using something that's called a parser. And that parser relies on something called a grammar. That grammar is not that different than what you would think of with a language like English or whatever. The difference is computer science grammars for computer science programming languages are really strict. They have to be completely, again, there can't be any ambiguity. English grammar and other natural language grammars typically have a fair amount of ambiguity in them. Programming language grammars do not. They have to be very clear cut. And so what I'm doing here is I'm curious about, anyway, this isn't gonna make a lot of sense, but this particular grammar uses this, and I'm familiar with this. I've used this in some of the projects that I work on. It's actually used in some of the code that you guys use for the playground. So this particular grammar is part of this project called Antler. And the idea is that this grammar allows it to parse Java source code. And so you can see, and actually you can see things that you might recognize here, right? So here's all the primitive types that we've been talking about. And so the idea is when it sees this particular token, it knows that it's a primitive type. The reason I pulled this up is I wanted to see where void appears. And there's only one place in this grammar where you can see this token void, I'm pretty sure. It looks like there's 8 uses of it, but I think that's the only place where you see this. Yeah, okay, perfect. And so the idea here is that void is this really special token in the Java language that only gets used in exactly one place, and that's in a method declaration. There's like one other place in the grammar where you can use void, but it's basically another type of method declaration. And so, and you can see this is type or void. So basically what you can put as the return type for a method is any Java type and void, okay? So anyway, basically that's the only place that you see void used, is to just as a stand-in for a method to indicate that it doesn't return anything. It's not a type, it can't be used to declare a variable or whatever. And so because void's not a real type, it doesn't really have any relationship with null, right? Because I can't, void is kind of like, void is the absence of a variable at all, right? Void is like nothing, right? So I'm trying to think of a metaphor, right? I mean, if we think about our variables as like a box, right? And there's a value in there and I can change the value, right? Null is like an empty box, right? There's nothing in there at all. It's like a box that should be able to store a string, but nobody put anything inside. Void is like there's no box, right? No variable here. And so I think maybe that's a way to think about it. The other thing to point out is that a void method cannot return null. So we'll try this. It's going to say unexpected return value, right? And so the idea is like, this is like I tried to hand back an empty box, but Java was like no box, right? This method doesn't return anything. And so if I don't return any variable, I can't return an empty value. If this returned a string, Now I can return null. That's okay. So null can be assigned or returned or passed in place of any variable that's of an object type. Same thing with int. I can't return null here because I can't assign a null value to an int. So, going back to our box analogy, it's almost as if, primitive types are like boxes, but they have to have a value in them. If you take a value out, you got to put another one in right away. You basically that's reassigning. Object types are like boxes, but they can be empty. If I assign null to it, then there's nothing in there at all. It's just an empty box. Void is no box. Void, there is no variable there at all. And so hopefully that helps clear that up. That's a really, really good question. I mean, clearly the two things have some relationship to each other. But in this case, void is just this very, very weird token that is only used on the left side of a method declaration when it does not return anything. Good question. All right, so I think at this point, I will let you guys work through today's walkthrough. I hope you do go through it. It's really cool. This is probably one of the most interesting methods I've had a chance to implement in this class, particularly this early on. It was a lot of fun to do. And so I hope that you'll enjoy that explanation. I will stick around for a couple of minutes to see if people have any additional questions. I think otherwise, we did well for a Friday. I'm going to run off for just 1 minute. If you do have questions, queue them up in the chat. When I get back, I'll handle anything that people are interested in talking about. All right, so great questions. One of the things we're starting to do, and I'll make sure that we get this up today and as part of yesterday's lesson, is we started to actually have staff go through and record walkthroughs for the old homework problems. We're going to keep doing that. I haven't been checking, but I'm hoping that a lot of them are done. I will put up one for, I'll put up a spot for it for yesterday's homework, and then we can have a staff member go through that with you. Or for you is just a walkthrough that you can look at. Difference between non-equal to null and so Java doesn't have a double equal syntax. So if I say s is equal to null, I can print, I can use this. Oh, what's it mad at me about? Let's see here. What happened here? Oh, sorry, this is a homework problem. What am I doing? Okay, that's the problem. Yeah, all right, so if I do, this is a really good question. So if I do this works fine. I can test for not equal to null, right, which is also fine. This syntax, Java doesn't have a not double equal syntax. JavaScript has that syntax, but Java does not. JavaScript, just for clarity, is a completely different programming language. I was confused about this for probably an entire decade until I started to work a lot with JavaScript. JavaScript is like not related to Java. I know it's like Java plus another word, and that's what confused me for a long time, but JavaScript is like a totally different thing. In JavaScript, there is both a triple equals operator and this particular bang double equal sort of not equals operator. I don't want to talk about what they do because this is of course on JavaScript, but it'd be a good question for the forum in the off-topic area if you're curious. So Java doesn't have this operator, right? In Java, you got your equals, you got your not equals. That's all we got. But these work with null the way that you would expect, and these can be useful. Not equal to null. I don't know how, I guess I do use that sometimes, right? When you're doing input validation, typically you're checking against something being null because you want to escape, right? Like if somebody gave you a null input to your method, you want to run away. You don't want to handle it. You want to return some value so that the parts of your method that assume that the string is not null or whatever input that you're working with is not null work. Good question. Let's see here. Are we going to use string compare to this weekend? No, I don't think so. Maybe you could, but yeah, you'll see when the weekend homework comes out. One of this weekend's homework problems is quite challenging. The other one is quite straightforward. So it's a mixed bag. Let's do the string algorithms and strings homework. Let's take a look at this one. Let me see what. Let's see. I'm trying to remember what the two were. Let me see if people have actually got to these yet. So it looks like one of the staff members has recorded a walkthrough. So if you go to the site, you log on, it looks like one of our core staff members has actually put together a walkthrough showing you how to approach this particular problem, how to declare the whatever. So this is really exciting for me. One of the things that we built into this new platform that we're using this semester to deliver the homework and deliver the lessons is this ability for core staff to participate. We may open this up to students actually at the end of the semester for you guys to add some stuff as well in exchange for extra credit. So for now the staff should be doing these. I haven't been keeping track. It looks like we have one done for that one. Looks like somebody went through and did a bunch of them, and I wish I remembered who this person's name was, but I'll go fix that so that I can hover over them and figure that out. So looks like someone has gone through and recorded a bunch of walkthroughs for you. So I would check those out, and we'll put up one for the algorithms and string problem here. For now, since you asked, and since I'm here, and might as well enjoy a few more minutes together, I'll at least walk you through kind of the setup here, right? And so we can kind of we'll sketch out an algorithm together, and hopefully that kind of gets you started in the right direction. So whenever you have a problem like this, if you want to make some progress immediately, you can always just figure out what the method declaration looks like, because that's always a useful place to start. I'm here. It says I'm going to write a function called reverse. It should accept a single string argument and return that string reversed. And so there are 4 parts to my method declaration. I want to think, how do I parse those sentences and figure out what those 4 parts should be? And remember, I can also run my code at that point, even if it's wrong, and make sure that I'm not getting the error that indicates that something's wrong with the design of my code, meaning that the method declaration is correct. Okay, so the first thing that the sentence says is that my function should be called reverse. So I can put that in there. So I know I need a parameter list, and I need a return type, and I need something to go in the body. So my parameter list, it says it should accept a single string argument. All right, so, and I can call that whatever I want. I'm going to call it forward, because reverse is what we're going to return. And then it should return that string reversed. And so from the second part of that sentence, you need to sort of be able to figure out that if I'm returning a string, the return type of the method should be string. All right, so let's try this. I'm just going to return the empty string for now as a placeholder value, just so that I can check. So clearly this is not right because I'm not doing anything, but I didn't get the class design error that I would have gotten if I had tried this, for example, right? Because I didn't do this right, or if I had done something like int and I was returning 0, right? I get these type of errors. Okay, so I've got my method declaration set up, and now what I need to do is deal with the body of this method. So as the problem setup implied, there are a couple of different ways that we can approach this. But this is one of those places where fundamentally I need to be able to actually extract characters from the string. I need to be able to figure out how do I get at each character, because if I can extract the characters, then I can put them back in the other order. And so my suggestion is, let's try to figure out a way to print. That'll be our first step. First of all, let's write a loop that prints the characters in forward order. Okay? So I'll say write loop that prints characters in order. So this is in the order that they were in the original order they were in the string, right? And so this is, on some level, a for loop that's pretty similar to ones we've written in the past, where we can say for in I is 0, I is less than forward dot length. And remember, it's a string, so length is a method that I need to call in order to achieve the length. And now here, the first thing I can do is I can just print off I. And in this case, it's not, I'm not seeing that those print statements. And actually, that's actually a bug in the system. I'll go fix that later. You're supposed to be able to see what you printed. So if I was experimenting with this playground, I would say, okay, let's see if I see the right indices here, 0, 1, 2, 3. And so actually, let's go ahead and do that. Let's work on this in one of the playgrounds first, and then we'll come back and put it in there. So this can go in any one of these. Just throw it in this one. And I'm going to try calling it with let's use test, because that seems to be one of the inputs that the grader is using. Okay, so now what I'm seeing is I'm seeing the 4 indices, 0, 1, 2, 3 printed, and that's good because those are the valid indices for a string of length 4. Now I need to figure out how to get the character at that indice. The write-up here suggests looking at several different methods. So there's this char@at method, right, which if I open, returns the char at the specific index, okay. And that, that's that is actually the method that in this case I'm going to want to use. So the first thing I'm going to do is to try to print the characters one at a time. So now instead of printing the indice, let's print char@, and we'll pass I. And again, one of the things I really want to encourage you to do, first of all, use the playground to test things before you plug them into the grader. Now again, I will fix the problem where the grader's not showing output. That's not the case. I'm sorry, I didn't realize that until now, so that's on me. But we'll fix that, particularly before you guys get to a quiz. So this is now my expectation is this prints TEST on one line. Let's see if that works. Okay, it does. And so what I'm doing here is I'm trying to build up to a solution very incrementally. I'm not trying to solve the whole problem at once. I'm just trying to kind of go through the different pieces that I think I need on the way to a potential solution. That way, if I make a mistake, I'm going to find it right away, and I won't, I won't be trying to debug like 4 or 5 different problems with the same piece of code. All right, so now I need to figure out a way to get things in reverse, and there's 2 ways to do this. One way is I pull characters out of the string, the forward string in order, and I put them into the reverse string backwards. Or I pull characters out of the forward string in reverse order, and I put them into the reverse string in forward order. That makes sense? So in the first approach, I would pull out T first, and I would put it at the back of the new string. And then I would pull out E and put it at the back of the new string. And pull out S and put it at the back of the new string. Pull out T and put it at the back of the new string. And by doing that, again, I'm pulling things out of the forward string in forward order, and I'm putting them into the reverse string at the back. The other alternative is I pull stuff out of the forward string from the back and put it into the front of the new string. So I put T into the front of the new string, then S into the front of the new string. Well, sorry. I pull T out, right? I append T to the new string, then I append S to the new string, then I append E to the new string, and then I append T to the new string again. So if I do that, right, if I pull them out of the back and put them into the front, that will also that should also work. So again, we can do this either way, right? For now, we have a forward loop, and so let's see if we can figure out how to put them into the other string in the opposite order. So the first thing I'm going to need is I'm going to need a string to return. I'm not able to modify the contents of forward, and I wouldn't want to anyway. Instead, what I need to do is to build a new string. And I need to initialize this string when I create it. And even though we were talking about null today, null's not the right way to initialize the string. I want to initialize it to be empty. And so now, the question is, how do I, what you're going to see is, so I print this, I see reverse, but then I don't see anything else because I returned reverse. And so there was no additional output, right? And so now I have a character and I have a string. And I also know that I can combine a character and a string using string concatenation. So let's try one way of doing this. And again, to be honest, I'm not exactly sure even which way is going to work. But what I know is that there's only 2 ways to do this. And so we'll try both. So the first thing we'll try is we'll say reverse is equal to reverse plus forward.char at I. And I'm going to take off this print statement. Try this. Okay, so that doesn't seem to have worked, right? In this case, the characters are still in the same order. In this case, I'm putting the new character at the back. So let's try putting the new character at the front. Bingo. Yeah. So if I take characters out of the original string in forward order, and I put them at the front of the new string, that has the effect of reversing the string. And so if I take this code that I've just completed, not the loose code, just the method declaration, and I stick it down here, I'm going to expect that this is going to work, and it does. So that's one approach. The other approach, right, so remember when we did this, so if I change this, it's going to fail because I'm actually just recreating the original string. The other approach here is to go through the original string backwards. So I'll just modify my loop here slightly to do that. And then this also works. Right? So those were 2 variants on this. There are other ways to do this. You could have created an array of characters and filled in the array backwards. That's another way to do it. This is probably a little bit simpler than the methods that use arrays. Okay, I hope that was helpful. We will get, like I said, we will get the playground, the homework fixed so that you can see the output from your code. That was always my intention. I realized that we boo-booed there, so I'll fix that stat. And we are, like I said, we are backfilling in new explanations of old homework problems and walkthroughs by staff. So please go check those out. That'd be a great way to review. Good luck. So as a reminder, that the help site is offline now for the next 24 hours. We will be back tomorrow on Saturday at noon. I suspect that tomorrow will be a busy day because tomorrow's homework problem is hard. And so, please put it on your schedule, check the homework out in the morning, do a little bit of work on it before the help site opens, and then, we'll have staff available to try to kind of get you across the finish line. So hope you guys enjoy your Friday, what's left of it, and I will see you again on Monday.